Hi, I'm Sari Marshall.
Hi, I'm Corinne Johnson.
And we are juniors at Sullivan High School in St. Louis and a member of FRC Team 8077. We are a community team that meets at Made for Kids, which is a branch of the Magic House located on Delmar, near Kings Highway in the city. Our team's full name is Delmar Robotics Engineers at Made for Kids,
but we call it Dream.
If you've been to Made for Kids or seen pictures of it, you may not recognize it here. But this is what it looked like last spring before it opened. At this time, our team didn't yet have a number or name or members, and the Magic House was already filling up the calendar with events like birthday parties. But the Magic House has supported FIRST for a long time, and the idea of having a team meeting at Made for Kids made sense. So a special plan was made to allow our team to meet in the evenings and Sunday morning.
At the St. Louis Public School District, the superintendent for college and career readiness is a big fan of FIRST. She let us use her booth at the Summer Urban Expo for recruiting kids. Other recruiting stops included the STEM lane at Worldwide Technologies Raceway and a lunchtime robot invasion at my school, Soldan. Thanks to all this recruiting around town, our team had 16 student members from 6 schools: Metro, Soldan, Parkway North, Trinity, Hazelwood East, and a homeschool. Mentors were recruited at Made, the serious makerspace that is the downstairs neighbor of Made for Kids. Our mentors come from all walks of life. We have several retirees, including one from Boeing and one from Monsanto. We have a professor from WashU, an industrial designer, a factory manager, a current Boeing employee, software and security consultants, our own Magic House staff member, and more.
During the summer and early fall, we connected with several retiring teams and arranged to receive their unneeded robot parts and material. We ended up with lots of it, several trailer loads full, in fact. You can see how one of our mentors got good at backing a trailer up the ramp to our second floor storage area. Other adventures included transporting a section of carpet from the real FRC team, a 12-foot long roll that had to be bent and had to transport. Getting this stuff sorted out and organized was the hard part though, and continues still a year later.
When the school year began, our team started having one meeting per week with a very ambitious early goal. There is a preseason event called Gateway Robotics Challenge, or GRC. FIRST brings the whole field from last year's game, sets it up at Lindenwood University, and area teams are invited to bring last year's robot and this year's new team members and play a tournament. Whole rookie teams like ours get special treatment. A rookie team usually has to borrow a robot, but we had a 2-year-old robot in our assortment of stuff. We decided to modify this robot to play last year's game, and with only 4 meetings to do it, it was a challenge. First, the robot was too tall. Last year's game had a special height limit on the robot, so we had to partly disassemble it and cut it down. Second, the robot had a bunch of pneumatics on it. In other words, stuff to use compressed air to move things on the robot. Since we had 4 meetings to repropose this robot, we took all the pneumatics off and replaced one air actuator with an electric motor, much simpler to get working. Just in time, we had a robot that could manipulate the hatch covers to put on the spaceships in the game. Some of the hatches were high, and we had a functioning lift that could raise the hatch covers up high enough.
The night before the event, we loaded in, parking our tiny trailer in among the big trailers of the veteran teams, and started checking out the robot, testing all its functions. In transit, a wire for our limit switch had come loose, which allowed our lift to go past its lower limit. Pop! 30 minutes after loading, the shaft on our lift gearbox sheared right off. However, putting heads together to solve problems in a hurry is what FIRST is all about. 3 teams volunteered to help us find replacement parts. The next morning, we had enough parts to rebuild our gearbox twice. Within an hour, our robot was good to go, but our adventures were just beginning. During our first match, we learned a few lessons about how the field control system interacts with the robot. During a period of the match called Sandstorm, when the drivers cannot see the robot, we were planning to operate the robot by camera, but we were told that the field control system will actually run our autonomous program. Our autonomous program? The only autonomous program we had was made by a mentor as a programming test for a different robot. We didn't know what it would do with this robot. We never did find out what the robot did, but when the Sandstorm screen came up, we saw our robot had traveled about 10 feet and it was still upright. We fixed this problem in time to use the camera for the next match, but we lost the first match. In fact, we lost every match during the qualifiers. Qualifier matches are played with random alliance partners, so our alliance partners also lost whenever we played with them. But we had fun and learned a lot. For the elimination bracket, where captains pick alliance partners, we were picked last by the 8th seed captain. Somebody had to be picked last, and we were happy to fill the role. We were just happy to play more matches.
In the first round of the elimination bracket, our alliance won the best of 3. We were happy, but it didn't sink in right away what had happened. In fact, it didn't dawn on us until we were told we needed to change our bumper colors from blue to red. Red is the color that the top seed alliances start with. We were switching because, as 8th seed, our alliance had played the number 1 seed and beaten them. Our robot had to play at least one match in the next round, so we changed our bumper colors and got ready. Our match in the next round ended in a tie score, and everyone waited to hear what the tiebreaker rule was. The tiebreaker rule was, team with the most hatch coverage placed wins. Our alliance had more hatch coverage placed, thanks to our robot. We won that match, and then our alliance won the final round. And we took home a winning banner and a plaque that hangs proudly at Made for Kids. Those banners are rare, and we appreciate how fortunate we were. But as they say, a big part of success is showing up, and we worked hard to show up.
After GRC, more recruiting. The chess coach from Soldan High School joined Dream, and he in return recruited most of the chess team. A taxi service helped students get from Soldan to Made and back home after meetings. For the rest of the fall semester, we started building a robot using the standard kit of parts to learn about the standard chassis and waited for the early January kickoff. Kickoff was on January 4th at Lindenwood University, and getting everyone there required a combination of taxi and carpooling. But the taxi let us down, so we organized a carpool scramble to pick up everyone. By this time, our team was getting good at solving problems, and we all made it to Lindenwood in time to see the reveal of the new game, Infinite Recharge. After kickoff, we spent the day with another veteran team, 931 Perpetual Chaos from Gateway STEM High School. 931 is one of the oldest FRC teams in the country, as you can tell from their short team number. As a veteran team, they look for the rookie teams to mentor, and they adopt us and became our big sister team. We were also happy to find some chess fans on 931, and part of the day was spent out in the cold playing chess on the life-size chessboard at the Chess Hall of Fame in Central West End. But that was after several hours whiteboarding at the Scofley Library, brainstorming with 931 about the new game, ways to score, penalties to avoid, and robot design priorities.
Holiday party got snowed out, so in January we had a post-holiday party with gifts and a game of charades. With our diverse group, we had no idea if charades would even work, but it was amazing. At another meeting, we decided to have another game night in order to get more familiar with the Infinite Recharge rules, and we played both Jeopardy and Family Feud. In the Family Feud game, teams had to come up with answers for things like, name 5 ways to score during driver-controlled period. In the Jeopardy game, we had questions like, this part of the game is paramount. What is safety?
After kickoff, our weekly meetings went to 3, Tuesday and Thursday nights and Sunday mornings. This number of meetings is very small compared to some other FRC teams, so we had to make the most of our time together. We started by rolling our carpet, laying out the dimensions of one end of the field, and running around like robots to simulate how the game would be played. We operated the standard chassis we built and ran it over things the field are like speed bumps to see what would happen. We added new members, and every new member was given a tour made for kids by Tim, our Magic House staff member. Tim introduced new members to the cool maker equipment, including a laser etcher he used to make name tags out of wood for everyone. Slowly, we made considered options and made design decisions. We had to commit to certain choices early on, so we could order required parts before those parts got sold out. And even then, we ended up waiting weeks for key parts to arrive. We made the decision to use the most advanced motor controllers available, and it was a little like the moon landing. We chose to do it because it was hard. Even our most experienced mentor had never used these motor controllers on a robot, so it was a great challenge.
Team 913.
Wait, what?
What?
It's Team 931, not 913.
That's what I said.
No, it ain't.
Right?
Oh, Team 931 invited us to one of their Sunday meetings, and we helped on some of the things they were doing. They were busy building game elements like the hanging pipe and also prototyping a shooter like ours. Both teams used the same programming language, so our programming mentors were able to compare notes.
Over the next couple of months, we built a prototype shooter to launch power cells, which are basically Nerf volleyballs, into a target about 8 feet in the air. And we built a prototype conveyor system to get balls from the front of the robot up to the shooter. But oddly, one important part of the game was left out of our design, and that was hanging. In Infinite Recharge, robots can score large points during the endgame by attaching to a horizontal swinging pipe and lift themselves off the ground. Our robot design still lacked this important function, but time and weight constraints left us no way to add anything in time for our competition. One thing that really sapped time from our schedule was a component of the turret. The turret at the top lets the shooter swivel around so that the robot can aim perfectly at the target, even if the robot isn't facing straight at it. When the parts finally arrived for the turret and we began putting it together, we found that the chain would not fit on the turret. Did we have the wrong size chain? After much back and forth with the manufacturer, we decided the sprocket was just made wrong, and we had to hack it to make it work. Like every bad dentist, we ground off many of the teeth, leaving just enough for the chain to grip the sprocket and move it.
With 1 week to go before the competition, we began shooting balls at the target to figure out the details of the targeting program. We have a thing called a limelight, which is bright green LED lights that reflect on special reflective tape on the target, and a camera that sees the reflected light and figures out where the target is relative to the robot. If that sounds complicated, it was really the easy part. The hard part was the motor controllers, as we mentioned earlier. They were hard enough, but we also made some of our own cables connecting things, and after one long meeting troubleshooting, we discovered one of them was bad. Shortly after replacing that cable, our robot was hitting the target like magic.
This is our t-shirt design for our uniforms. We know that many teams made shirts that feature the Star Wars theme of infinite recharge, but our team is different from most teams, and we like to be different. Taking inspiration from the popular Renegade dance, we named our robot Renegade. In our shirt design, Renegade is scratching for friends using the part of the playing field called the control panel, which robots have to spin to activate different levels of power during the game.
Here is our finished product, including one proud team member at the first day of the competition on March 12th. This picture was taken shortly after the competition was canceled due to increasing concerns over the pandemic. And at this time, teams were getting their only looks at the other team robots before packing everything up. Here's a list of features of Renegade. Renegade has a jumpy but effective 6-wheel drive with pneumatic tires. It has some field-related drive controls using a gyro. It has a shooter that self-aims and automatically adjusts speed for target distance, using the Limelight camera system. It has a mode for automatically chasing and picking up power cells, yellow balls, using a Pixie Cam and a Raspberry Pi. It has a program for the autonomous phase of the match, where it scores 3 balls in high goal and sometimes 1/3 in the inner, highest scoring goal, and movement off the starting position using encoders. It has a manipulator for the control panel, which is the thing that Renegade is scratching on our shirts. The control panel manipulator is automatic, using a color sensor to track the position of the wheel.
Back at the very beginning of the season, recall when we broke our robot's lift motor at GRC and several teams helped us fix it. We made many important connections at GRC, one of which was with a team in Wentzville, the Ratchet Rockers. Thanks to that connection, we learned that the Rockers were opening their practice field for a scrimmage on March 7th, a few days after the canceled competition. At this time, it was permitted to have gatherings of less than 10 people, and so the Rockers invited 10 teams to bring no more than 10 people each, and we were lucky enough to get on that list.
FRC recently announced that because many teams did not get to play Infinite Recharge due to the canceled event, the game would be reused as the game in 2021. This announcement means that teams will not have to build a new robot for next year, which will be good since next school year is certain to be unusual and stressful anyway. FRC also announced that rookie teams like ours will retain rookie status for 1 more year, which means we will be eligible for the Rookie All-Star Award again. If we were to win that award, we would receive an automatic invitation to the World Championship in Houston, Texas, and we are hopeful that the World Championship will take place in 2021. FRC's announcement for FRC means we can continue working on Renegade all the way through to March 2021 competition. We can't wait to make it better and add a hanging mechanism.
Thank you so much to all of our sponsors. We all learned so much. Many of us were seniors, and we know they will cherish memories of being on the inaugural Dream Team. The rest of us cannot wait for the next season of challenges to conquer and dreams to dream. I'm gonna dream big.
We're gonna dream big.
You should dream big.
Thank you for helping us. Dream big.